Okay, welcome to I² Maths Academy, where numbers and variables actually made mastery. Today we are going to be looking at a question under integration by parts. Here we are asked to evaluate integral x tan square x dx. Now solution. Now remember, for integration by parts, we said integral u to v is equal to uv minus integral v du. Yes, this is integration by parts. Now, in this case, let u be equal to x and the v be equal to tan squared x dx. Yes, let u be equal to x and the v be equal to tan squared x dx. Now, let's begin. Du all over dx. Now, du all over dx, when you differentiate x, it gives 1. Yes. And when you cross multiply, we have the u will be equal to 1 times the x. So it means the u is equal to 1 dx. Yes, that's the value of our du. Now, let's begin. If the v is equal to tan square x dx, it means v will be equal to integral the v, which is the same as saying integral tan squared x, then here we have the x. Now let's look at the integral of tan squared x dx. Now recall that sine square x plus cos square x is equal to 1. Yes, sine square x plus cos square x is equal to 1. Now, when you divide through by cos square x, it means here we have sine square x all over cos square x plus cos square x all over cos square x is equal to 1 all over cos square x. Now, we all know that tan x is the same thing as sine x all over cos x. It therefore means that sine square x all over cos square x is tan squared x. So we have tan square x plus cos square x all over cos square x is 1. Now the whole of this is equal to sec squared x. So it therefore means that tan square x is the same thing as sec squared x minus 1. Yes, when you take this plus 1 to the other side, it gives this. Now let's take note of this. Yes, let's take note of this. Tan squared x is sec squared x minus 1. So it therefore means that our v will be equal to integral. Here we have tan squared x dx, and it's the same as saying integral. This tan squared x is sec squared x minus 1 dx. So it therefore means that the value of our v now will be equal to, when you integrate sec squared x, it gives tan x. Now remember, we said integration is the reverse aspect of differentiation. So when you differentiate tan x, it gives sec squared x. So it means when you integrate sec squared x, it gives tan x. So when you integrate the sec squared x, it gives tan x minus, when you integrate 1, it gives x. Now this is our v. Yes, this is our v. So now we are saying here that integral u to v is equal to uv minus integral v du. So it therefore means that integral x tan square x dx will be equal to, now the value of our u, remember we said let u be equal to x. So it means here we have x. Yes, our u is x, and our v here, look at the value of v, tan x minus x. So here we have tan x minus x, then minus integral v. And now the value of v we said is tan x minus x, then the u. Now the value of our du here, yes, look at the u. Our du is 1 dx. So it means here we have 1 dx. So therefore, integral x tan square x dx will be equal to, here we have x in brackets, we have tan x minus x minus, now let's look at this now. Let's look at tan x. Yes, let's look at tan x. Now to integrate tan x, remember integral tan x is the same thing as saying integral tan x dx is integral sine x all over cos x. Then here we have the x. Yes. So now to integrate this, we just pick let u be equal to cos x. Yes, let u be equal to cos x. So the u all over the x. When you differentiate cos x, you have minus sine x. So it means our du here will be equal to minus sine x. Then here we have the x. Yes, that's the value of our du. So it means our dx now will be equal to the u, that's minus the u all over sine x. So it therefore means that integral tan x dx, which is the same thing as integral sine x all over cos x. Now the value of our dx now is the u minus the u, yes, minus the u all over sine x. Yes, minus the u all over sine x. Now this sine x, now this sine x here will go with this sine x. I remember we said let u be equal to cos x. It means the whole of this now will be integral tan x. The x will be equal to integral, that's minus because of this negative sign. We have 1 all over cos x is u. So we have u, the u. So when you integrate 1 over u, it becomes minus ln u. Yes, minus ln u, which is now the same thing as saying minus ln, the value of our u is cos x. We have minus ln cos x. So that's the integral of tan x. So coming back to this, yes, coming back here, it means integral x here will be minus ln cos x. Then here when you integrate minus x, it becomes minus x squared all over 2. So here, let's say partial constant plus c1, and here let's call it c. Yes, so it means the whole of this now will be equal to, we have x in brackets, we have tan x minus x. Now minus minus is plus, so we have plus ln cos x, minus minus is plus, so we have plus x squared all over 2 plus c. So this is the integral of this. So therefore, integral x tan square x, the x, will be equal to, we have x tan x minus x plus ln cos x plus x squared all over 2 plus c. So this is the solution to this problem. Thank you for listening.